Okay, so this is where we left off with last time. We got a little bit of content to get through because we want to make sure to stay on schedule and get to esterification. That will be taking place tomorrow. So with this, I do believe 13th, yes, there's a paper that's due today. We'll get to that in just a few moments. All right, so as we continue, the purpose or some of the properties of these acids, as you can see, okay, we have illustrated whether it's a strong acid, doesn't have to be that, but a strong base. We used sodium hydroxide, potassium hydroxide. Those are both considered as strong bases then. Now, one of the aspects that these numbers, really not important, okay? Well, the author goes in to say it's important with the fact that you don't need to know those numbers. That's what I meant to say when I say they're not important, because what it deals with, some of the properties of it, is absorption. And that's why having this at such a lower melting point is going to be an advantage for us, because it helps us absorb some of these substances more readily or more easily. I believe that's what it talks about on our next slide. I'd like to think you don't have to write all of this. Maybe you don't even have to write any of it. Okay. Good, good, good. And one of the aspects that if we have a good grasp on these reactions, we're setting ourselves up for the stage of being successful when it comes to this process of esterification, which just means you are forming an ester. It follows a very same path as what these do, what we had illustrated with this reaction. And then when it comes to hydrolysis, okay, whether it's making an acid in esterification or hydrolysis, taking the water out, those reactions also go both ways. And that won't mean anything to you until we get further on with the content here. So having that lower melting point is going to be an advantage. Again, maybe it says it on the next slide. Oh, so it can be absorbed into the body. That's right. I figured it was up there somewhere. Chalk another one up into the win column last night. Great job, ladies. Got the train going in the right direction. Silly question. Do the same ladies that play volleyball play basketball as well? Okay. I guess I don't know if that's a silly question, but So what we see happening then, okay, if you take an acid, okay, then you react that with a strong base, okay, that makes that carboxylate salt. And leading into the physiological conditions, okay, that's again where it leads to that being able to be absorbed into the body, okay. So I want to make sure we get through this one, that one. Okay, so that leaves 1, 2, 3. Okay. Oh, this is where we left off with, right? So we got 3 left, if my math is correct. I don't mean to be jumping back and forth, but I know it's early in the semester. Oh, I didn't take roll. I bet you that's what it is. That's why it rings twice and then it stops. Yeah. I would have done it on the other computer, but once I leave that screen, it stops recording, then I got to start all over again. Okay. So the simplest salt, this is going to be another one of them aspects that you know the answer to this, but you just don't realize that you know it, okay? These are fairly complex salts that we would be making. No one would argue with that. What is the simplest inorganic salt that you may be able to answer? And we don't want to Google it. It's the simplest salt. What do you think that might be? I'll let you think about that for a couple moments. Just guess. Okay, that's half of it. Sodium chloride, that's right. So when we think of this sodium chloride, if you have to utilize that in a recipe of some sort, I don't know, or you spill some salt. And once you put water on that or into anything for a recipe, does that salt disappear? You're nodding your head, yes. Why is that? Do you think? Anybody? Just that you were on a roll, so I thought maybe you would keep going. Does it dissolve in water? Yes, so that makes it extremely soluble. That's what we're getting at here. So when you put it into any form of liquid, unless you're cooking with pure oil, which I don't think you would do that. And if there's any type of moisture or water in there, that salt will dissolve in there because it's extremely soluble. So what that means then is if that is a salt and it's soluble, so are these substances, which are these carboxylate salts that we can absorb into our body very easily, are also very, very soluble. And for this here, some of you have thought about going into nursing. Is that correct? And with that, sometimes what you would possibly come, and I don't know this from experience, I just know this taking classes through different professors. What do I say? Going down the line of keeping the teacher's certificate current. The last one I had, she was a professor up at SDSU, has lots of nursing students go through there. One of the things that you would have to learn, or you don't know how to do this yet, but one of the things you would learn is diluting solutions, because it's one of those aspects you don't walk up to the medicine cabinet and pull out the solution to give to the patient. It may be in a concentrated form, so you would have to be able to dilute that substance down, okay? And whether that's something that you would have to perform, well, I don't know. It depends on what type of nurse you may decide to be, whether it's a, I suppose, what would you say, a clinical nurse, ER nurse, OR nurse, any one of those. So if you have an aqueous solution that's concentrated, you may have to dilute that down. But again, you don't know how to do that yet because you haven't been taught that. I just said the same thing to another student. We Googling this? Oh, okay. Now, aliphatic chains, those are what the most common types of compounds we dealt with, where you have chains lined up in a row. That's different than aromatics because those are your benzene structures. So aliphatic chains are linear, and then aromatic structures are a special type of ring structure. So then on Friday, when that rolls around, out in the gallery there, there's no need to log on, or won't be anything to see, because we'll be doing this over in the lab, okay? Saponification, process of making this soap, okay? So we take some oil, okay? Because it says you can obtain some of these carboxylate salts, which is a type of soap that you could use as a cleaning agent, kind of like a detergent as well. And we use a form of vegetable oil, okay? And then also a very strong base, like sodium hydroxide, and you mix the two. And one of the things, I think you have to go through a separation process, if I remember correctly. And then you got to let it dry, and then will begin to, let's say, evaporate, dry out, and then harden. And then you can actually use that as soap. And your great-grandparents probably did that on the farm, where lye is certainly a very, very strong base. So they had access to these fats and oils. That might be from what, do you think? Pigs. And I wouldn't be a stretch to the imagination, probably cattle too. But I think it's probably more common in pigs, because you can still buy this product, I'm willing to bet, off the shelf in grocery stores that you get from the fat of pigs. Has anyone ever cooked with lard before? I think it gives a much better flavor in anything you cook with. But the problem would be what? It is not good for you at all. Okay. So again, we'll be doing that process then on Friday. Okay, where does that put us? Okay, here. This will be the last slide that we do for today. So what this soap does then, okay, these substances are not water soluble. So what you have then is this carboxylate salt then, which will break up the grease, and then the water will wash it away. Does anyone ever check their own oil anymore in the car? You open the hood, you're nodding your head yes. So maybe take a paper towel, pull the dipstick out, and put the dipstick back in the motor, pull it back out, and then you can check it. Well, if you get that oil on your hands, of course, if you go into the sink, wash it off. You're going to wash it off, but there's probably still going to be some sort of residue. So that's why we use soap, because it breaks those molecules apart. And wash it away with water. All right. That went a little quicker than I thought, which is fine. So therefore, what we have coming up, we're going to talk about this tomorrow, okay? And then let's see here. When we get to the naming of these esters, which will be next week, okay? I guess I really don't know what you would consider has been the most difficult process of this semester. But to me, the esterification and hydrolysis, it's very, I think it's easy to see, but we want you to learn it and draw it in a specific manner. And we'll get to that later on next week. So that's all I got. We'll catch up to you next time.